The advantages gained by applications using fibre optics. For a long time, the world ran on copper wires. Remember landline telephones? They were essentially strung together with copper wire. Along came fibre optics and everything changed. Copper phone wire had limited bandwidth. Fibre optics offered 1,000 times as much bandwidth over distances 100 times further. Fibre optics were able to pack a lot of punch into smaller, less heavy cables, which gave them a competitive advantage, especially in crowded cities where underground space was and is limited. Why applications should use fibre optics? Fibre optics offer many advantages. They can handle a staggering volume of data over long distances. Fibre's low rate of bit error means it's pretty resistant to electromagnetic interference. Fibre optics transmit data or signals using light, so information cannot easily be stolen. Virtually noise-free, fibre optics come in small sizes. If copper wires were like big, boxy desktop computers circa 1988, fibre optics are like the slim and efficient tablets and smartphones of 2017. Finally, fibre optic cables are made of glass or plastic. They're thinner than copper cables and easy to install in various places. Fibre cables also have the ability to accommodate more bandwidth if needed. Why many companies prefer fibre optics? So why would companies want to use fibre optics? Phone companies would do so for the clearer phone calls. TV stations would want to for the clearer TV pictures and sound. Computer companies would use fibre optics to transmit digital signals via the internet. Fibre optic cable, furthermore, can be flexible, allowing it to be used in places where it would need to bend and change shape. Examples of industries that benefit from fibre optics. Consider one particular field where fibre optics has really changed the game: the medical industry. Fibre optics allow medical workers to see places in the human body in a way that's easier and more comfortable for the patient than in the past. Take, for instance, bronchoscopes. These instruments are used by doctors to look into the inside of a person's respiratory tract. A doctor can manipulate the bronchoscope to look for tumours in the lungs. Fibre optics makes this possible. Similarly, endoscopes use fibre optics to help show doctors what's going on with a patient's organs internally. Patients are sedated and the procedure is relatively painless. In essence, fibre optics allows medical personnel to see inside parts of the human body clearly in order to diagnose and treat people with various medical conditions. Fibre optics are small enough, flexible enough, and advanced enough technologically to help patients have less pain, less risk, and less scarring. Couple that with a faster recovery time, and it's no wonder that fibre optics have made checkups, operations, and hospital visits less scary or difficult than before. Besides the medical industry, fibre optics are used in other industries such as mechanics. If you were to use your naked eye to try and look into a pipe or engine, it would be hard to see what's in there. Furthermore, the insides of engines, for example, can get smoky and hot. It's not the kind of place you want to be sniffing around as a human being. However, what if you could send an instrument into the interior of, say, a rocket engine? Indeed, that happens often thanks to fibre optics, which are used to see inside parts of airplanes, vehicles, and even spacecraft. Utilising imaging systems, workers are able to find problems more easily than in the past and respond to them before people get hurt.